Howdy folks. What we're going to do in this video is we are going to, it's actually kind of an easy thing, we're going to learn how to identify what is called a confidence interval. And you actually already know how to do this if you've done all the other stuff in my class so far. It's very similar to doing a middle percentage interval, okay? Something that we did only. The way we're going to calculate the middle percentage is the same, but the way that we actually calculate the left and the right numbers is a little bit different, because instead of using a standard deviation, we're going to use a standard error calculation. So give me just a minute, and I'm going to put a problem up on the board, okay? All right, folks, here's the question. We got some researcher out there in the world. He collected some data, or she collected some data, on some important variable, right? A sample of 53 revealed that the sample mean in this sample of 53, the sample mean is 123 and the sample standard deviation is 10.7. And so here's what it says. It says, using a 92% level of confidence, determine the confidence interval for mu. Also, what is the margin of error? Well, the margin of error, that's a part of the confidence interval. As we're doing the confidence interval, a part of the procedure is to identify the margin of error. So we'll do that as we're going. For now, what we're going to do is, I'm going to show you how to identify a 92% confidence interval. And then after we're done with it, I will briefly explain what it means, okay? So here's what we have to do. This is kind of like, and you're going to need a calculator and you're going to need a z-table, okay? This is kind of like a middle percentage problem, which I've already shown you how to do. Because what we're looking for here is we're looking for the middle 92% of cutoff scores. That's basically what we're getting here, is the middle 92% of cutoff scores. So if you can remember how we did that previously, you're basically going to do the same thing. And so if you recall, the very first step, in fact, I'll put some steps down here. Your first step in solving this problem is to convert the percentage to a decimal. Okay? Then subtract it from 1. And then divide by 2. That's what you're going to do. You're going to take whatever percentage, whatever the confidence interval percentage is, and you're going to convert that percentage into a decimal. Then you're going to subtract it from 1. Then you're going to divide by 2. Well, the way that we can convert 92% into a decimal is we can do 92 divided by 100. That's what percent means. Percent means per 100, or out of 100. 92 divided by 100 is 0.92. Okay? And now, actually, let me do this in a different color. I'm going to do it in green. So here's a green marker. So we'll do 92 divided by 100 is equal to 0.92. Then we're going to subtract 0.92 from 1. So we're going to do 1 minus 0.92. And that's going to give us 0.08. You can do it in a calculator if you need to, but it's 0.08. Then we're going to take that number, 0.08, we're going to divide it by 2. So 0.08 divided by 2 is equal to 0.04. Equals 0.04. And here's what I'm going to do. I'm going to put a couple more zeros after it, because this is a p-value. So this is a p-value that we're going to look up in the z-score table. Okay, so we're going to get our z-score table here, and we are going to look up. We're going to look up 0.0040, and 0.0040 somewhere in here. See, we're getting there. 0.0166, 0179. There we go. We're looking for what's closest. Here's 0.0197 and 0.02. Oh wait, that's 4. I'm not looking for 2. I'm looking for 4. There it is. 0409, 0401, and 0392. So we're looking for the closest one, 0392 or 0401. 0401 is closer, right? So that is the one we're looking for. So this is negative 1.75. So we have negative 1.75 as our z-score. All right, so that's the second step. Find the z-score that goes with the p-value. It's the p-value that you found in step 1. All right? And so p-value of 0.0400 is associated with a z-score of negative 1.75. And here's what we're going to do. We're actually going to do plus or minus that z-score. So it's not just negative 1.75, because again, it's a middle percentage. And if you remember our middle percentages, we always found a z-score and we always did plus or minus that same z-score. Okay? So we're going to use plus or minus 1.75 for our confidence interval. Okay, so that's step 2. Step 3, let's come over here. Step 3 in this procedure is you are going to use a formula. And what you actually are going to need is you're going to need this z-score, and you're going to need the sample size, the standard deviation, and the sample mean. And what you're going to do is you're going to use the formula x bar plus or minus the z-score. By the way, that plus or minus is this plus or minus. This is the same plus or minus. So you're not going to put plus or minus plus or minus. That doesn't make any sense. We're just doing plus or minus. Z times a standard error. Now, do you recall that standard error is a standard deviation over the square root of the sample size, right? Okay, and here's our standard deviation, only instead of the population standard deviation, we're going to use the sample standard deviation, and here's our sample size right over here. So it's going to be x bar, that's right here, plus or minus z times s, standard deviation, over the square root of n. So this is our standard error, okay? So now all we have to do is plug our numbers into this formula. So our x bar is 123, 123 plus or minus z, which is 1.75, 1.75 times standard deviation s, which is 10.7, 10.7 over the square root of n, which is 53. So over the square root of 53. Now, here's what you're going to do. This right here, this piece, the plus or minus this, that is your margin of error. So when you calculate ignore the mean and ignore the sample mean for a minute. When you do 1.75 times 10.7 over the square root of 53, whatever value that is your margin of error. So when I say what is the margin of error, I want you to multiply the z times standard deviation over the square root of sample size. Okay, so let's do that right now, and then we'll come back for the 123 in a minute. All right, so let's put here 4. Identify margin of error. Identify margin of error. Okay, which is just simply z plus or minus z times s over the square root of n. Okay, so in this case, let's get a calculator somewhere around here. Here's one. Lots of calculators lying all over this room. All right, so let's see here. We got 1.75 times, parenthesis, I got 10.7 divided by the square root of 53. Square root of 53. That's going to give me 2.572. 2.572. So, plus or minus 2.572. That is the margin of error. Plus or minus 2.572. So I'm going to come over here. What is the margin of error? Well, that's plus or minus 2.572. That's a part of my answer here, right? Because the question says, what is the margin of error? Okay, good. And now the question said, well, what is the confidence interval? Well, the confidence interval is the rest of this. We're going to do, so step 5 is identify the confidence interval. Identify the confidence interval. Okay, and the confidence interval, what we're going to do for that is we're going to do 123 plus or minus this number. So it's going to be 123 plus or minus 2.572. So this is your confidence interval. And if you want to know what the actual interval is, because sometimes you can just write it as this, as the mean plus or minus the margin of error. Sometimes you might actually have to calculate the numbers. Well, in that case, we just have to do 123. Start with minus 2.572. And that gives us 120.428. 120, in fact, let me put it over here. 120.428. Watch this. I'm going to put less than or equal to, and then I'm going to put a mu, right? Because what we're finding is a confidence interval for mu. Confidence interval for mu. So mu, we're approximating that mu is between 120.428, and then we got to do 123 plus 2.572. That's going to give us 125.572. 125.572, and this is our confidence interval. Okay? Let's do another example, and then afterwards we will discuss what a confidence interval means. All right, here's another problem. It says we got some researcher collected data on some important variable. They had a sample size of 107, and they came up with a sample mean of 12, and the standard deviation, the sample standard deviation is 1.58. And now the question is, using, that should be n, using an 87% level of confidence, determine the confidence interval for mu. What is the margin of error? Well, the first thing we're going to do is we're going to convert our percentage into a decimal, subtract it from 1, and divide by 2. If you want to pause this and do this before I do it, you go ahead and do that. Okay, but I'm going to go ahead and work on it right now. All right, but you can pause it and then check your work as I go, after you play it again. All right, so 87 divided by 100 is equal to 0.87. Then we're going to subtract that from 1. So 1 minus 0.87 is equal to 0.13. Then we're going to take that 0.13 and divide by 2. 0.13 divided by 2 is equal to 0.65. No, excuse me, 0.65. Sorry, my brain went somewhere else. So 0.13 divided by 2 is 0.065. And so that is our p-value. All right, that's our p-value that we're going to work from. So over here, we want to find the z-score that goes with the p-value. So if our p-value is 0.065, and I'm going to put another 0 on there because p-values in the table are 4 decimal places. So I need to get a z-table to turn it into a z-score, and I got to go inside of the table to find 0.065. All right, 0.0618, 0.0643, 0.0655. Well, which one of those is closer? 0.0655 is 0.0005 away. 0.0643 is 0.0007 away, so we're going to go with 0.0655. And the z-score associated with that is negative 1.51. Negative 1.51 becomes a z-score of negative 1.51. And remember, we want it to be plus or minus 1.51, and that's going to help us find our margin of error. So we're going to go to step 3 over here. And in step 3, we're going to use our formula for the confidence interval. We're going to do x bar, that's the mean, 12, plus or minus the z-score, which is 1.51, plus or minus 1.51, times the standard deviation, which is 1.58, divided by the square root of n, square root of 107. Now, we can identify the margin of error. This part is the margin of error, right? The 1.51 times 1.58 over the square root of 107. So let's go ahead and get a calculator. We're going to calculate the margin of error. So I'm going to do 1.51 times 1.58 divided by the square root of 107. That's going to give us 0.231. Now it's actually 0.2306. Let me talk about this. 0.2306439. I like to go to 3 decimal places here on the margin of error. And look what happens at the 3rd decimal place. We got to look to the 4th place. That's a 6. So that's going to round this 0 up to a 1. So it's going to be 0.231. All right? So it's going to be plus or minus 0.231. That's our margin of error, plus or minus 0.231. Then it says identify the confidence interval. So the confidence interval is going to be this whole thing. The margin of error is plus or minus 0.231, and then 12 is the mean. So it's going to be 12 plus or minus 0.231. And so now we're going to take this and we're going to write out our confidence interval. First of all, the margin of error is plus or minus 0.231. That's our answer for the margin of error. And our confidence interval for mu, put mu here. Oh, hang on. Mu is going to be in between. We're going to go 12 plus 0.231, and that's 12.231. And then 12 minus 0.231, and that's 11.769. And this is our confidence interval, okay? That's 2 examples that we just went through. We seem to go through them pretty quick. You've got a procedure here, so you should be able to identify any kind of confidence interval. We could do the exact same problem with the same numbers, only change the percentage, the confidence percentage, or the level of confidence. If we change this percentage, it'll be a new margin of error and a new confidence interval. So that's a whole separate problem. On this worksheet that I made, you have the same mean and the same sample size and the same standard deviation, but I give you 3 different problems with 3 different levels of confidence, 3 different percentages, okay? So now the question is, what in the world does this mean? What does it mean to have an 87% confidence interval and to have these numbers here? Okay, well, it's a little heady, it's a little conceptual, very theoretical, so I want you to buckle in, and I'm going to erase some stuff, and then we'll try and explain it, okay? All right, folks, I'm going to try and explain this confidence interval, and I just realized as I was erasing everything and rewriting it, you probably already noticed this, but when I was writing my answer down a minute ago, I had the answers completely backwards. It was technically correct because I had these symbols switched around, but I put the larger number over here and the smaller number over here. And if you were confused and you were like, man, I need to ask Mr. Ryan that question, well, here I am to answer the question right now. Yes, I made a bonehead move. It was technically correct, but that's not really how you should have written it, or how I should have written it, and you shouldn't write it that way either. What we're supposed to do is put the smaller number on the left, the larger number on the right, and then put a less than or equal to here and a less than or equal to here. Okay, so now that I've cleared that up, let's talk about what does a confidence interval mean? No pun intended. Okay, so the meaning of a confidence interval goes like this. Remember, that was we came up with this confidence interval based on an X bar, a sample mean, and a sample standard deviation, right? 12, standard deviation I think was 10.7, and a sample size of, no, it wasn't 10.7. Sorry, standard deviation was 1.58, and the sample size was 107. That was it. Okay. Now, this is just one sample of billions of samples or trillions of samples. Okay, it could be a Google samples. Okay, we know that there are lots of different samples that we could take with a sample size of 107, depending on how large the population is. If the population is like 5,000 and our sample size is 107, this is a lot. It's a very, very large number of possible samples. Okay? And so any one of those samples would give us either the same mean or a different mean. But what we want to know is, what is the likelihood that the sample that we chose is like the actual population mean? That's what we really want to know. And we can't know the population mean. And so we could take lots and lots of different samples with lots of different sample means. So we could write billions of different possible sample means that go along with this population. And so here's what a confidence interval means. An 87% confidence interval says that 87% of all of the possible samples that we could take. Remember, there's billions or trillions or quadrillions or whatever, huge, gigantic number of possible samples that we could take. And when you think of all of those possible samples that we could take, what we're going to say is that 87% of them will have the actual population mean within the interval that you come up with. Now here's the thing, is that there's no real way of knowing whether this particular confidence interval is one of those means, one of those sample means. But what we do know is this, is that the higher the confidence interval percentage, the more likely it is that we have selected a confidence interval that does include the population mean. Okay? And so this is a meaningful statistic, this idea of doing a confidence interval. I understand that the meaning of a confidence interval is sort of difficult to wrap your mind around, and maybe you'll have to watch this video 100 times, or maybe you'll have to go look it up on the internet. But this idea of a confidence interval, the more you learn about statistics, the better you'll understand this. Okay? For now, just make sure you know how to calculate a confidence interval, and then we'll, from there, over time, I think you'll begin to develop what a confidence interval means. Okay? Well, that's it for this lesson, and I hope you have a great day.